All right. Hi, everyone. Good afternoon. And I hope you had a lot of interesting sessions. Actually, I was listening to the last session, which was also very interesting, related to the role of AI in health sciences and healthcare, which is a very interesting and very innovative things going on there. Um, First of all, I would like to appreciate the organizers of this summit to provide a platform spreading the awareness of microelectronics and AI within the tech as well as the healthcare industry and many other industries. As many of you already know, the semiconductor industry is flourishing with a high pace and momentum. And at the same time, it is also facing a lot of challenges in the form of demand and supply imbalance. Maybe you have heard a lot in the previous sessions from the semiconductor industry. So these supply and demand imbalances are in the supply chain as well as in the form of skilled professionals who can drive the ever-increasing needs of this industry. I'm hoping that most of you guys are from the engineering background. So that's why this session will be much relevant to you, especially with people from mechatronics, electronics, and microelectronics departments. That being said, there is a huge opportunity for countries like Pakistan, which has around 65% of the population younger than 30 years of age. So compared to US and Europe, it gives us a lot of advantage in terms of young talent like you guys, whose energies and capabilities can be leveraged to bring Pakistan to the forefront of this technology revolution driven by Industrial Revolution 4.0. So I personally believe that open source technologies like AI, OpenAI, ChatGPT, and RISC-V, and many others, and there are a lot of open source tools and flows, and they can play a tremendous role in developing the necessary infrastructure in underdeveloped countries like Pakistan. Okay, so this is a short introduction about RapidSilicon. So I'm providing you a mission statement that we have at RapidSilicon. RapidSilicon is a US-based company, which has the largest subsidiary in Pakistan. So we have a design center in Lahore, which is one of the key design centers across all the sites that RapidSilicon has in different countries. So at RapidSilicon, we believe that open source technologies like OpenAI, RISC-V, OpenLane, and OpenFPGA can enable and empower individuals as well as organizations to challenge the status quo in the semiconductor industry. So this rapidly flourishing industry is expected to reach $1 trillion US dollars in sales by the end of this decade. So our vision at RapidSilicon is to enable small organizations, even individuals, to make their contributions to this thriving industry by leveraging digital technologies and platforms. RapidSilicon is led by a diverse group of industry veterans, entrepreneurs, and open FPGA inventors, where we believe that we can deliver the reprogrammable system on chip with the speed and ambition of a startup. So current supply and chain imbalance that we talked about shortly in the industry due to digitization, IoT, 5G networks, data centers, and autonomous driving, and many other market segments actually. We are exploring solutions to minimize the time to market and the product development while keeping the functionality as flexible as possible to meet the demands of the various industry segments and applications. So our solutions to the current industry trends are powered by AI, ChatGPT, and OpenFPGA, as well as RISC-V. So with these innovative solutions, the time to market of the customized programmable chips can be reduced substantially by 60%. The reprogrammability of the chips is vital to compete with ever-growing demand of this chip complexity. So we are deploying our international award-winning AI-enabled EDA tool named Raptor, and it has the potential to compete with any commercially available and reprogramming tool, and it's exploiting the full potential of digital innovation. We are also leveraging the open source frameworks like OpenFPGA and OpenAI to develop the reprogrammable chips with lowest cost to compete with industrial players in this arena. So this is a brief introduction of what we are doing at RapidSilicon and what is our mission statement. A short introduction about myself. My name is Arhan Yaqub. I'm working as Director Engineering at RapidSilicon, as well as the General Manager, where I'm responsible for countrywide operations, business operations, as well as the engineering growth of the organization. I came back to Pakistan with a vision to establish a semiconductor industry, or at least to contribute to my potential to this industry in Pakistan, and to lead our design center that we established here in Lahore with the name of RapidSilicon Lahore Design Center. So prior to joining RapidSilicon, I was working in Germany in various different semiconductor industries. And I have overall 14 years of experience in the semiconductor industry, in automotive, consumer electronics, as well as in medical devices. In addition to my current role at RapidSilicon, I'm right now also studying at the University of California, Berkeley, and Technical University of Munich. I'm pursuing my executive MBA. And prior to that, I had a master's degree in chip designing from Technical University of Munich back in 2010. Okay, so if we talk about the product portfolio at RapidSilicon, so we have product portfolio which is pretty much broad and covers large market segments, including industrial automation, consumer electronics, automotive, medical and health, high-speed communication, audio, video, broadcasting, and IoT devices. So you can see that our product can be deployed in all these market segments. And the reason behind this diverse portfolio is that there is a reprogrammability and the flexible architecture of the RapidSilicon devices that can fit applications from various market segments to run on our devices. So our first product, Gemini, that is expected to tape out in September 2023, has an anticipated market volume of 30 million units per year to be deployed in different market segments that are mentioned in the slide. So our teams at Lahore Design Center, as well as at other locations, are committed to meet the requirements of each market segments, especially related to automotive and medical, as these markets require a huge emphasis on functional safety and security. So we are deploying cutting-edge technologies and state-of-the-art tools to meet the quality and performance parameters set by these industries. So this slide actually flashes the potential distribution of 30 million units to various markets, out of which industrial automation has the largest share, as you can see already in the numbers. And it is followed by audio and video broadcast market segments. We have a plan to slowly transit to automotive and healthcare segments to capture the maximum margin. And it might take us a couple of years because there are strict requirements on the function safety and ISO 26262 standards by the automotive industry. But these industries are also in the plan of our developing our products in those domains as well. Okay, so right now, as you can see, that there are 4 major pain points that any semiconductor market segment is facing right now. First of all, the growing complexity of the applications in the area of AI, ML, edge computing, 5G networks, autonomous driving, hyperscale computing and data centers, etc. They're putting enormous pressure on the complexity, performance, and functionality of the semiconductor chips. So these growing demands have long been served using latest technology nodes to improve power, performance, and area. These are the key parameters in any chip design. However, there is a certain limitation on the technology nodes due to associated cost and capital requirements to continuously scale down to the size of the transistors. I think you guys have already learned in your university that there is a Moore's law that says the size of the transistor is shrinking every year to meet the demands of the industry. But there is a certain limitation on that. So we have to come up with novel approaches that can improve the power, performance, and area of the chips while keeping the cost within the limits. For that purpose, we have to improve the reprogrammability of the chips and have to make domain-specific architectures to meet the requirements of different applications. By domain-specific architectures, I mean the underlying hardware that you have on your chips will meet the requirements of certain domains and certain market segments. So this will overall improve the power performance and area of the chips. And these reprogrammable and domain-specific chips demand the extensive use of FPGA IPs. That means these are the reprogrammable hardware in our system-on-chip solutions. Another major concern that we have to address is the longer time to market of the complex chips. As you know, the modern applications and compute requirements are growing so rapidly that hardware development life cycles can be the potential bottleneck of these advanced applications to run on the required hardware. We need to address this problem by some innovative solutions to reduce the time to market and make advancements in our product development life cycle. The third one is the chip quality. So the quality of chips is another major pain point that chip industry is facing nowadays. As you can imagine from the first 2 points, that due to increased complexity, quality assurance is a huge concern before deploying these chips into sensitive and safety critical applications, especially if you talk about automotive or healthcare. The functional safety and security are at the highest point. So we need to think through it properly beyond the traditional approaches to meet the quality as well as the time to market requirements. Because if you spend too much time on developing a chip, then you might miss the time to market of those chips, and you may potentially lose the revenue from your products. So RapidSilicon is taking major steps to address this problem and have provided innovative solutions using AI-enabled frameworks to improve the quality of the chips. And we will discuss it very shortly. Last but not the least is the cost of the chips, which is rising significantly due to major imbalance in the demand and supply of the semiconductor devices. To meet the requirements of the industry, chip manufacturers are dependent heavily on the extensive third-party IPs, proprietary EDA tools, and higher cost of production. I think some of you who are linked with this semiconductor industry or doing some internships or training programs, you might have heard about very expensive EDA tools, expensive third-party IPs and verification IPs, and the physical design. All these tools are pretty expensive. And in order to stay competitive in this industry, companies have to solve this piece of puzzle. And the companies who will solve this will lead the industry in the longer run, because chip cost is increasing very significantly due to the complexity of the chips and the requirement to reduce the time to market. So there are traditional and non-traditional ways to lower the cost of the manufacturing, and RapidSilicon is investing heavily to enable the open source technology to reduce the cost of the chip. So RISC-V processor is a great example in this regard, and it has democratized the processor market. Similarly, open source tools like OpenFPGA and OpenAI have the potential to replace the expensive proprietary tools as well as chip manufacturing processes to reduce the overall cost significantly. Okay, so this slide explains the traditional solutions that any semiconductor company is deploying to reduce, to come over these pain points that we have discussed already. So chips complexity, for example, to address this problem, you can have design reusability. You can rely on third-party IPs, because if you cannot design all the IPs by yourself, because it will take a long time, and of course you can miss the time to market. So that's why you have to rely on third-party IPs to meet the requirements of the chip's complexity. And the third one is, of course, you might compromise on certain features of your chip by reducing in order to reduce the time to market. The second thing is that you have to reduce the time to market, right? So what you can do is you can intensify the resources. You can do a lot of design automation that will make your product development lifecycle faster. And you have to do a lot of agility in your product development. In order to ensure the chip quality, the traditional solutions are, you can use off-the-shelf IPs, which are pre-verified, and you don't have to verify and invest on physical design of those IPs. You can facilitate the integration of the IPs. You can reduce the features, because higher features or the complex features means you have to put a lot of emphasis on your chip quality. So you can reduce the features that can still meet the requirements of the customer or the application, but you can ensure the chip quality. And the last but not least is you might compromise on the innovation if you have to ensure the chip quality. And the last one, which is very critical to reduce the chip cost, what most of the semiconductor companies are doing right now is they are outsourcing their lot of work to underdeveloped countries. You have seen already that there are a lot of companies in Pakistan and then if you look at India or Bangladesh and many other Asian countries, that they're getting a lot of outsourced projects, and they are providing services because of the lower cost, lower engineering cost, as well as the better quality that they need to deliver. The second thing that you can do to reduce the chip cost is automation and test optimization. Then you can, of course, compromise on the innovation. That means you are developing some chips based on the requirements of the customer, but you are not investing heavily on the innovation because you are already meeting the requirements, and that is the least that you can do to deliver your chips. And the last one in this regard, but not the least, is R&D, research and development cost reduction. So when you have to reduce the cost of the chip, of course, you can reduce the R&D cost, which will not be innovative as it is required by the industry, but you will still be meeting the requirements of the industry. So these are all the traditional solutions that every chip industry is doing right now to to address the pain points that we saw in the previous slide. However, as you know, when the technology and business issues appear overwhelming, like we see here, that we have a lot of unknown things that we need to resolve. So sometimes the traditional solutions do not work as expected. So what is the solution is we have to bring a lot of innovation in our solutions, right? So this is exactly what we are trying to do in order, in addition to all these traditional solutions, we are also deploying a lot of innovation in our RapidSilicon products and frameworks that we'll see in the next two slides. Okay, so the first one is RapidSilicon Innovative RACIF platform. So RACIF stands for RapidSilicon AI-powered System-on-Chip Integration Framework, as the name implies. So RACIF is our in-house built framework to integrate different components of the system on chip using ChatGPT. So this framework allows us to integrate third-party IPs like design blocks into the SoC using their standard metadata like IP exec files. User has to specify the requirements of the IP based on the SoC specs and provide these specifications to this RACIF framework. The RACIF framework is based on the ChatGPT that takes in, you can see in this flow diagram that it takes in the IP exec files from the third-party IP vendors and the SoC definition by the user and integrates the IPs into the SoC with certain functionality. The output of the RACIF framework is an SoC RTL that has all user specified IPs integrated and verified. So you can see that so IP catalog and SoC definition, these are the inputs to this framework. And then you have to provide the IP's instantiation, standard IP port list, and interrupts and DMA interfaces, and so on and so forth. And this framework integrates your IPs into an SoC and provides you an SoC RTL. So if you guys are already familiar with system on chip, you already know that there are a lot of IPs that we need to integrate into our SoC. And it takes a lot of engineering effort, and of course, a lot of engineering cost is spent on this integration. So by using the AI-powered solutions like RACIF, you can actually reduce the SoC integration cost significantly, and it also gives you a lot of confidence because there are a lot of test cases that this framework will run on the SoC, and it will ensure that the integration of those IPs and the connectivity has been verified. So currently there are proprietary third-party tools that offer automated SoC integration already, but these tools are very expensive, first of all. And secondly, most of them do not deploy AI in their frameworks because AI and ChatGPT is something very new right now in the microelectronics industry. And ChatGPT has opened up a new horizon to build this framework with lowest cost and highest quality. So we are already deploying the ChatGPT in our innovative RACIF solution at RapidSilicon, and our teams are working extensively on this framework that has the potential to reduce the cost of the chip development significantly. The second tool that we are developing right now using AI is Raptor. So Raptor stands for RapidSilicon AI-powered predictable timing optimized result. So Raptor is a RapidSilicon proprietary tool that is used to program the reprogrammable part of our system on chip. As I discussed earlier, that in our system on chip, we have a reprogrammable IP that we have integrated into our devices. So these reprogrammable IPs need some software or the tool that can reprogram these specific IPs into our SoC system on chip. So Raptor is based on open source tools chain that performs linting, synthesis, placement, routing, timing, and bitstream generation of the designs to be programmed on the chip, as you see in the flow diagram. So we have deployed AI to optimize the result of all these open source tools that are being used in Raptor to enhance the power, performance, and area of the designs to be programmed on our FPGAs that are the reprogrammable part of our chip. So these are the two major frameworks that we are developing right now in RapidSilicon that are purely based on AI and ChatGPT, and they have a potential to address the pain points that semiconductor industry is going right now. And of course, it can enhance the efficiency of the product, as well as it can reduce the time to market, and it has the potential to lower the cost of the chips.
Our AI big.
Okay, so there's a short demo video that will describe how we are leveraging the ChatGPT to build our proprietary tool, RapidGPT, which is an AI-powered coding co-pilot. So most of you have, from the engineering background, have already done some type of coding in C, Verilog, System Verilog, and many other languages. So RapidGPT is kind of acts as a coding co-pilot for you. So you can say goodbye to the days where you were struggling with complex HDL code, for example. So our AI-driven co-pilot understands your HDL code directly within the Visual Studio Code Editor. It's like having a coding buddy that comprehends your intentions and helps you make changes effortlessly. So I will run this video very shortly, and you can see that we can provide instructions in our Visual Studio in a natural language, and then it will translate it to the design that you want to implement in Verilog or System Verilog. So right now it's showing an example with a Verilog code, and you can see that it will take all the instructions from the user in simple and plain English, and then it will translate it to the IP that we want to build with this with the Verilog code.
AI-based RapidGPT allows you to co-pilot your design code or even generate your design based on the specifications in natural language. In the example, we are generating the code for UARTIP that is used for serial communication between the two chips. We have specified certain parameters based on our requirements and asked RapidGPT to generate the code for this IP.
Okay, so as you can see that we have provided the instructions to the tool that which IP we want to integrate and what are the parameters, what are the settings that this IP should have. In our case, it's a UART IP, which is a serial transmitter and receiver. And we can provide him all the parameters that we want to implement, and then it codes the whole transmitter as well as the receiver module of the IP. So you can see that you don't have to code anything. It will just translate your plain English into a full-fledged Verilog code for your IP that you want to implement. Okay, so if you talk about the market fit, so whenever you have some new solutions, you have to think about what is the market requirements for these kind of innovation and innovative tools. So if you talk about the market fit, our AI-based or AI-powered solutions that we discussed, they have the capability to reduce the SoC development cost significantly. And the second thing, which is very important, is you can reduce the time to market to accelerate new product introduction process or the new product development process. The second thing we have to take care is what is the market advantage of these kind of solutions. So you can already see that we have a very unique solution, which is based on very latest trends in the digitization like AI and ChatGPT, and we are actually leveraging them to get the advantage in the market that we can reduce the time to market without compromising on the quality and also reducing the cost. So it's a better quality and first time right approach for chip development. So these are the major advantages of deploying these AI powered solutions. I think when you are in the tech industry, the only thing that should stay constant is the change. As you see that we have a very disruptive solution that can revolutionize the chip development and programming. And we are also advancing the EDA tool through RapidGPT. So Raptor is our EDA tool, and we are deploying a lot of AI features in Raptor that is improving and enhancing the productivity of the tool itself. Last but not the least is about the staging, how we will stage these kind of AI solutions in the future of RapidSilicon. So right now we believe that we can do a lot of technology licensing to our key partners. That means we can sell solutions to our key partners, and they can also deploy in their new product development lifecycle. In a later stage, so right now we are also deploying, of course, these kind of solutions in our new product introduction and development processes. And in the future, we have a plan or a staging plan or strategy that we will commercialize these kind of technologies to all our competitors as well as the whole semiconductor industry. So these are the major strategy items that we are doing right now, and the AI powered solutions are helping us in standing out in the crowd of the semiconductor industry. Okay, I think although AI is bringing up a lot of innovative solutions in the microelectronics industry specifically, there are some associated challenges and risks that must be addressed properly while deploying these kind of technologies. So as you can see on the left pane of the slide, that there are a lot of challenges that we have to cope or overcome when deploying the AI. For example, you have to build up all the skill set that is required to fully leverage this technology in chip development. The second one is the development cost. Of course, when you have to develop the tools and processes and flows that use AI technologies, you have to pay some development cost, which is like R&D cost that you have to spend. But of course, in the long term, these kind of development costs will give you the benefit or the return of investment. The third one is the integration into the existing frameworks and tools. So in our microelectronic industry or the chip design industry, there are a lot of tools that exist from the vendors like Cadence, Synopsys, Xilinx, Vivado, and many other tools that exist in the chip design industry. So we have to integrate this kind of AI-powered solutions into those tools by ourselves, and of course we have to spend some effort in those areas to further enhance the productivity of those tools. Last but not the least is, as you know, that AI can help you in increasing the productivity of your coding as well as on your tools, enhancing optimizing the tools and many other things. But the thing that is lacking in AI is a creativity. So AI cannot conceptualize, strategize, and innovate. So these innovative ideas you have to bring by yourself, and AI can help you in executing those innovations and strategies with the highest pace compared to when doing it by humans. The risks that are associated using AI in the microelectronic industry, the first of all is reliability and robustness. So as I discussed earlier, that there are many industry segments like automotive, healthcare, where the safety and security is a major concern. So you have to address this risk that you don't have to compromise on reliability and robustness of those solutions that AI is bringing. So that means quality of results is one of the risks that you need to address when deploying the AI. The second risk is development time. Of course, when you are developing the AI solutions first time, there will be a time curve that you have to take care of. So there is a learning curve from the engineering team, and then also there's a development time for those tools. So it can actually increase the time to market maybe for the first products, but in the longer term, again, it will reduce the time to market for your upcoming products. Third one is accountability and governance. So as you know, AI doesn't know about anything about ethics, right? It doesn't have any emotions, it doesn't have any ethics. So accountability and governance is the thing that is quite risky right now, and especially in the chip industry, where you have a lot of NDAs, like non-disclosure agreements, and confidentiality of the chips and this kind of thing. So you have to be very careful when you're accountable and governance of the AI-based solutions. The last one, which is also talking about IP confidentiality, is when you are sharing your information of your chips or your IPs or any other solutions with AI, then there is a huge chance that it can be shared with the broader audience that you don't want to do actually. So IP confidentiality is another major risk that we have right now in AI, and of course we are working, and overall chip industry is working how to minimize these risks in order to fully leverage the AI in our microelectronic industry. Okay,